Hello friends, thank you for watching this video. I am Mohamad and I will be giving you today an introduction about Docker. So what we'll be covering today? First, what is Docker? And within that topic we're going to be covering what's a container, what's an image, what is a Dockerfile, and what is a container registry, and how everything fits together. Then we're going to be discussing the difference between a Docker and a VM. Then we're going to see how we can have Docker on our local machine, and then we're going to do the first Hello World application with Docker, and then we're going to be creating our first Docker image. Please like, share, and subscribe if you like this video. It will really help the channel. So, first, what is Docker? Docker is a container management system which allows us to package our application and dependency and configuration. So basically, it's a platform that allows us to convert our application into packages. These packages can be easily moved around and shared between different people. So for example, I can create one image or one package, I can host it somewhere, and other people or other developers can download that package or use them, or even we can deploy those packages to servers, and from there we can launch our applications. So Docker basically as well, it's used for automating deployments. So for example, once we create an image and we make sure that, or we create a package and we make sure this is what we want, we can just deploy it to our pipeline, and from there on we can automate the entire deployment process. And this can work locally on-premise, or it can work as well on the cloud. So what's a container? A container is an instance of a Docker image. We're going to explain what's a Docker image in more detail, but in essence, a Docker image contains all of the executable or the dependency of our application. And basically, a container is just an instance of that image. So for example, let's say we created an image of our web app. We can just initiate that web app, and once we initiate that image, we create a container. So for example, when we want to scale our application from one server to 10 servers, all we need to do is from one single image is initiate more instances of those, and every instance is called a container. Basically, all containers are based on a minimal OS, mostly on Linux environment. Also, there is a possibility for us to run them on Windows environment. But if we're gonna create images based on Windows, they can only run on Windows. On the other hand, if we build them on Linux, they can run on Linux as well as on Windows. So, what are the main benefits of containers? Containers are secure because they are a closed entity of code after they are deployed. They are run in isolation, so every container runs by itself. It doesn't communicate with anything else unless we give it a permission, usually within a Docker network. It's portable. Once an image is deployed, we can pull down this image anywhere, and we can actually initiate it. It's either be on the server, on our local machine, on a testing environment. It's way faster to start up from any normal web application because everything is ready for it. All it needs is just to initiate the command and it will start up the application. And it takes less disk space, usually because everything is compact and we only use what's really needed. And we use the published version of our application. So all of the files and all of the DLL are to their bare minimum. Now, what's a Docker image? As we mentioned earlier, a Docker image is the application binaries, dependencies, metadata, configuration, how it's gonna run. So basically, a Docker image is based on a file called Dockerfile, which is gonna be explained in the slide after this. And basically, we configure everything we need to make that application run. And once we have that Dockerfile up and ready, we execute the Docker command and we create an image of our application. Images are used to create a container, as we have discussed earlier. Usually, images are based from base images, which means, let's say we want to build a .NET application, we need to use our SDKs. So in order for us to build our application on .NET, we need to use a .NET base image, which is usually the .NET SDK image. In our coding part, we're going to be seeing how we can utilize base images to create our image. And basically, as we mentioned as well, Dockerfiles generates Docker images for us. So what's the difference between a Docker image and a Docker container? So this graph will illustrate the main difference. So as we can see here, we have one Docker image, which is the application source code, the binary, the configuration. And from one Docker image, we can initiate as many containers as we want. So for example, we have container 1, container 2, 3, and 4. All of these containers are exactly the same application, and they are based on the exact same image, as you can see from this picture. And for example, if we need more containers, all we need to do is initiate another Docker image and it will create a new container. So it allows us to easily scale our application up, and to easily scale it down as well. So what is a Dockerfile? A Dockerfile is basically the set of instructions that we need in order for us to create an image. So we write these instructions. There's certain commands that we need to follow and certain structure, but it's a very easy one to follow. And once we write our set of instructions, as soon as we write the docker build command, the Docker daemon will automatically pull that up and it will create a Docker image for our application. So this is a small screenshot. As we can see, we are pulling from a base image, which is our SDK, and then we are building restoring some packages, and then publishing it, and then giving it the command to run. We'll go in these in more details once we reach the coding part. What is a container registry? A container registry is a place where we can store all of our container images. That's it. So container registry can take all shapes and forms. So it could be a private one, it could be a public one, one container registry could be public and private at the same time. So it's a place where we can host all of our images, and it allows us to push our images, deploy them, download them, and basically manage them on the cloud. As well, Docker Container Registry can be available on-premise as well as on the cloud. A way to think about it, it's similar to GitHub. When GitHub we use for us to store our code, Docker Hub is the container registry, which is very similar to GitHub, where we can push our images publicly where they are available to everyone, or we can have our own private container registry which we can use. And within Docker Hub, which is basically the main container registry, we can find a lot of verified images that we can utilize. So how does everything fits together? So first, we need our Dockerfile, as we said, where we write a set of instructions. After we write the set of instructions, we initiate a command here, which is usually docker build. And once we initiate that command, a Docker image is created. And that Docker image is created, we can do two things with it. Either we can push it to a container registry. It could be a Docker Hub, or it could be Azure Container Registry, or it could be an AWS Container Registry. Basically, any cloud provider will have a container registry, or even locally on our own servers. And the second option for us is to create a Docker container. And basically, it's initiating that image. So, what's the difference between a VM and a Docker? So if we just take a look at this graph here, we can see that both VM and Docker utilize hardware, which is fine. Both of them needs a host operating system, which is fine. But the main difference lies on the third row here, the hypervisor and the Docker engine. So the hypervisor basically allows us to separate our main hardware into different small hardwares in order for us to install operating systems, and then install the configuration that we need, and then creating our application. So basically, we are creating multiple virtual machine based on our main hardware, or based machine. But when it comes to Docker, all we need is the hardware and the OS without any need to do any separation. Why? Because the Docker engine will be responsible to communicate with the main kernel of the OS, and on any application which using Docker will be able to utilize the Docker engine communication with the kernel. But here, when it comes in the virtual machine, every application will have its own OS, and every application will communicate with the kernel of that OS. So we have the main OS, we have the hypervisor, and then we have the guest OS, and the application will communicate with the guest OS in a virtual machine. While in Docker, the containers will be able to speak with the Docker engine, and the Docker engine will use the main OS kernel in order for it to communicate. So it's one less item to worry about, and it's less stress on the machine itself. This is why we can run way more Docker containers on a single machine than running on a VM. And this is why it's way faster to use Docker instead of virtual machine. Another main benefit is Docker is very lightweight. As we said, we don't really need to install a lot of operating systems. All we need is our host OS. We don't really need to have guest OS. So Docker is lightweight while virtual machines is heavyweight. Virtual machine performance is very limited to the hypervisor. So for example, if we put for the first OS, we decide we want to have 2 gigabytes. For the second OS, we're going to have 1 gigabyte. And for the third OS, we're going to have 500 megabytes. So every application is limited to based on the hardware configuration that we gave it. And we cannot really scale it up or down. In order for us to do that, we need to shut down that OS, change the configuration in the hypervisor, and then start up the guest OS again, so the application will take benefit. So it's really have limited performance based on the hardware virtualization. On the other hand, in Docker images, it will allow the application will allow to utilize as many hardware as needed based on the OS limitation. So for example, let's say this machine has 16 gigabytes of RAM. The 16 gigabyte of RAM will be shared equally between these 3 Docker containers, and in case we need more, we can configure our Docker engine to take more RAMs than we currently have. The last point that I want to discuss here is the app communication. So as we can see here within the virtual machine, every app is segregated based on its OS. So we have the first OS, which is completely separate from the second OS, which is completely separate from the third OS. So if app 1 wants to communicate with app 2, there is no direct way to communicate between these two. It's either have to be through an API where they'll be able to communicate, or for example gRCP, where they are able to communicate with each other, but there is no direct way for them to, or they don't even exist on the same network in essence, because they are completely segregated. While in Docker, if you're using Docker engine, this way easier, because basically we can create a Docker network and we can put all of these containers inside the same Docker network, and we can allow seamless communication between the two. So how do we set up Docker? All you need to do is need to download the Docker client to your machine and open a Docker Hub account. The links will be available in the description down below. Now, let's open our terminal and let's run our first command with Docker after we have downloaded and installed it. So this is my terminal and I'm gonna run this command here. Docker run hello world. And as we can see, we got unable to find image locally. It's pulling it up from the server. It's pulling it down from the server, and then it's running it, and we can see that to generate this message, Docker took the following steps, and it means that it's working. So what happened now when we run the small command? The command was Docker, which basically we're telling the Docker container, we're telling the terminal that it needs to communicate with a Docker daemon that is installed, and the Docker daemon is this. We can see it from here. And then we're telling it to run. Run is the hello world. Is the command that we want to execute against the Docker daemon. And then we're telling it the name of the image that we want to run. And in this case, the image name is hello world. I'll be providing a list of Docker commands at the end of this video and on the blog in order for you to check all of the basic Docker commands so you can get started directly. So let's explain in details what happens when we wrote that command. So first, within our terminal here, we wrote that command, Docker run hello world. So when we typed it in the terminal, this command went directly to our Docker daemon. And then the Docker daemon checked what is the command that we are trying to execute. It's run. So it directed the traffic to the run command. And then it took the image name that we wanted. And the image name is hello-world. So once we have the image name here, the Docker daemon will check locally on the actual machine or our own machine to check if we have that image locally. So if Docker daemon is able to find this image locally, it will return that image to the Docker daemon. It will create a container out of that Docker daemon, out of that Docker image, and then it will send the output back to our terminal. So basically that's the step in case we have that Docker image available locally for us. But in case that Docker image doesn't exist, which was our case here, it says that unable to find hello world locally. So what happened? So because it didn't find it, it went to Docker Hub, which is, as we said, is the main container registry that we have, image registry that we have. So it went there, it checked against Docker Hub, it was able to find it, and it requested it from Docker Hub. So Docker Hub sent back the hello world image to our local machine. Then Docker daemon checked again after that process has been completed, and Docker daemon found it locally, and then it went back to the Docker daemon where a container has been initiated, and then that output has been returned back to our terminal. And this happened all within a few seconds. So as we can see here, back to from our terminal, basically it wasn't able to find it locally, and then it directly knew that it needs to communicate with Docker Hub, and then it pulled it locally on our machine, and then it gave us the information that it has downloaded the latest version of Hello World, and then we got the output because it ran. So that's a very interesting way to see how Docker daemon works in the back, and how Docker daemons automatically communicate with Docker Hub. Now let's jump into coding. After we did our Hello World application, now it's time for us to create our own sample application and create our Dockerfile and build it. So in order for us to do that, we're gonna be needing the .NET SDK. So you can go, I will provide the links for them in the description down below. And we need an IDE, which is gonna be Visual Studio Code, as well as Docker to be installed on your machine. So first, in order for us to verify if .NET is installed, we need to go to terminal and type .NET -- version, and we need to see the version of our .NET SDK. In my case right now, I have the 5.0.200, which is the latest version of .NET. If you see any other number, it should be fine. If you see any errors, you need to re-download it and install it again. Now, let's create our application. We're going to be utilizing the .NET new keyword. So .NET new MVC app, and we're going to just call it Docker sample. Great, it should take a few seconds. Perfect. Now what we need to do is let's navigate to that folder and let's open it inside our Visual Studio Code. Perfect. So the first thing we're gonna do is we're gonna open our terminal. So under view, we're gonna choose terminal, and we're just gonna build the application to make sure that it's building successfully. So .NET build, this should take also a few seconds. Great, and then we're gonna do .NET run to run the application and see what's the output of our boilerplate application. So for that, let's open our web browser. And let's navigate to port localhost 5001. Perfect, we see Docker sample and we see home, privacy, and everything. So let's do minor changes to this. So in our index page, we're just gonna say welcome to Docker Hello World app, something like that. And let's delete this, we don't really need it, and let's stop the application and run it again. And let's navigate back to our web browser and refresh. Perfect, welcome to Docker Hello World app. That's great. So once we do that, now we're just gonna create our sample Docker file, and we see how we can containerize our application. So back into our IDE, let's stop this, and inside the root directory of our application, what we're gonna do is we're gonna right click, new file, and we need to call this file Dockerfile. So be very wary that D inside Docker needs to be capital and the file needs to be lower, and it should be one word. So once we click that, we have our Dockerfile ready. So first of all, we're gonna need a base image. As we said before, every Docker image is based on a base image. So because currently we are building a .NET app, we need a base image, which is gonna be the .NET SDK. So let's first write a command of what we're gonna do. So we're gonna get base image for our application. So that's the first thing we're gonna do. Second, we're gonna utilize the from keyword. So the from keyword is telling it where are we gonna get this base image. In our case, we're gonna be utilizing Docker Hub. So if we go to Docker Hub, and if we type inside the search .NET, for example, SDK, let's put .NET. Oh, okay, I found it. So .NET Core, yeah. So if we see here, it has been moved to .NET, and basically this is our main page for our .NET SDK on Docker Hub. And as we can see, there's a lot of images that we can use. So for us right now, we need to use the SDK. So let's find it here. We'll see .NET SDK. And within the .NET SDK, we have the latest version, which is what we want, which is the 5.0. So we're gonna copy this, and we're gonna paste it here. So because this is where we wanna get it. We're gonna get it from Docker Hub using this link. And we're gonna define it as our build environment, because this is gonna be the base image that we're gonna be building our application upon. So second, we're gonna be defining our work directory. What's a work directory? A work directory is where are we gonna be doing all of the configuration and all of the setup for our application for it to run within our container. So basically it's just like a folder inside our image, our base image that we got. So the work there, we're gonna call it app. And then basically once we have the base image and we have the work directory ready, what we need to do is we need to copy all of the CS file from our root folder here to inside this image and do a restore. So any packages that we might have installed, it will be available inside this image. So let's add a command first. We're gonna make it copy, let's put a space, copy CS file, and then restore packages. Great. So once we did that, now we need to write the actual command. We're gonna be utilizing the copy keyword, and then we're gonna put star.csproj, and that means that we're gonna take any file name which is which has a csproj extension, because a project can be could be formed of multiple csproj files. So this is a way for us to get all of them and restore them. And we're just gonna copy them to the root directory for us, which is gonna be work there at the moment. And after that, we're just gonna be restoring them. So we're gonna utilize the run keyword, and basically we're gonna utilize the .NET restore command. After that, after we made sure that everything has been restored and all of the packages is ready, we need to copy everything within our root file to the container. So how do we do that? Again, we're just gonna be using the copy keyword, and we're gonna put a dot. Dot means we're gonna copy everything, and we're gonna put a / and means here we're gonna copy everything from here to the work directory that we have created earlier. And next, it's gonna create very simple. Basically, we're just gonna publish everything now. So in order for us to publish the application, we're gonna be using again the run command, and it's gonna be .NET publish keyword, and then we're gonna be utilizing the C to make sure that it's the publish release version, and then we're gonna be specifying the output folder, and it's gonna be inside the app / publish folder. Okay, great. So once we have that ready, all we need to do is just build a runtime image and just copy everything that we want from the base image, which is the build environment image, to our new image. So In order for us to do that, very simple, we're just gonna do from again. Let's copy this will be easier. Copy. And then what we're gonna do is we're gonna specify a work directory inside this new image. And it's gonna be /app. And then all we need to do is copy stuff using the copy keyword. And here is the from means from which image we want to copy to the new image. So in our case, we want to copy from the build image that we have created to the new image that we have just have. So it's gonna be from the build environment and we're specifying where exactly. In our case, it's gonna be app /publish to the new root directory of this new image. And finally, which is the last point we need to do here, is we're gonna specify the entry point. So usually in .NET we write .NET run in order for us to run the application, and the .NET run usually initiate the main DLL file. Similarly, in this case, we need to specify the entry point. And the entry point, we're going to also be using the .NET keyword, so .NET. And the only difference is we need to specify the DLL name, and in this case, it's going to be the docker sample.dll. And that's it. So now we have our Dockerfile ready. Basically, let's recap what we did here. We just initiated a new base image, and we called it build environment. And we took the .NET 5 SDK version for that image. We created a folder inside that image called app. Inside that folder, we copied the CSproj file to it, and we did a restore so all of the packages are available. Then we copied everything else inside that image, and then we did a complete .NET publish to it. So inside the build environment, we created a new folder and we published everything to that folder. And then finally, we created the brand new image and we copied everything from the published environment to that new one. And then lastly, we specified the main DLL that .NET is gonna initiate when we run this image and basically when the container is running. So what do we do now after we have our Dockerfile ready? All we need to do is type docker build dot. So docker build dot means Docker is gonna be specifying to the terminal that we need to speak with the Docker daemon or Docker engine. The build keyword tells the Docker engine that we have a Docker file that we need to build and convert that Docker file into an image. And the dot means that the location of the Docker file is in the same file that we are, same folder that we are in. So it's inside this folder. So there's an extra command that I usually like to add, which is tag. So we can actually refer back to that Docker image that we have created. And for this tag, we're gonna call it Docker sample. And the Docker tag needs always to be all lower letters. And once we have that, let's click on enter. And now we can see, let's read what's going on one by one before we can. Oh, we have an error, so let's check what's happening and then we can fix the error. So first it says it's logging the definition of a Docker file, which means it's copying this Docker file to the Docker daemon to execute. And then it's saying, it's checking if there's a Docker ignore file. So what's a Docker ignore? A Docker ignore is similar to a git ignore. So in our case, when we're copying stuff from the root directory here to the inside of the Docker image, we don't really want to copy the obj folder or the bin folder or the properties folder. So we can create a new folder for a new file. We'll call it .docker ignore. And inside this Docker ignore file, what we can do is very simple, which is say we want to ignore the .bin /bin, and you'll say we want to ignore the obj, and this folder basically right now gets ignored, so they will not get copied from the root folder to our new container. And after that, it loads the metadata. So basically it goes to the base image, check if we have it locally. If it does, it will use it. If not, it will download it from Docker Hub. And then it says it found it locally, so it didn't download it. And then it says it has an issue finding the latest one. Okay, so the error that we were facing is because I misspelled environment. I forgot the V here. So now let's run the Docker build again and let's see what's happening. So let's go back. So we can see that the Docker ignore has been checked, and then we have the context, and then it checked for our .NET SDK. And then once we got the .NET SDK, we have built the Docker context for it. And then we started seeing the execution of our application. So first we can see that it have created the work directory for us, which is called the app. Then it copied everything, which has been completed successfully. And then we have run the application, then run the .NET restore, and then we copied everything to that folder. And then after that, what we did is we published it. And once we published it, we copy everything to the publish folder inside our new image that we have created here. And finally we have exported it and we gave it the name Docker sample. So right now, if I want to run it, all I need to do is type Docker run, and let me specify the ports that I want to communicate with. So -p, and let's say I want to communicate with port 8080, and I'll give it the name of Docker sample. One more thing that I would like to do, this is why it's not working. Let's go to our startup class, and for the web builder, let's specify to our program class, and let's specify which IP is available for our application. So we put web builder.use URL, and we specify that we want to communicate with this application on, let's say, for example, on port 8080, for example. Star, we'll put 8080, and all we need to do is save this, and then we need to rebuild that image again, and we can see everything is running all over again. All we need to do is rebuild this image and then run it. And now if we go to port 8080, oh sorry, so here it needs to be 8080. And now we can see the application is running because we mapped it from port 80 to port 8080, and we can see our application is running inside our container. So basically that's the final step in our video today. Let's do a quick summary of what we did. So we have went through what is a container, what's an image, what's a Dockerfile, what's a container registry. We checked the difference between a Docker and a VM, and then we saw how we can download the Docker to our machine. We went through our hello world step, and we see how does the Docker daemon communicate with terminal and what happens in the background, and then we created our first Docker image here. Thank you very much for watching this video. Please like, share and subscribe. Have a good day.